A very good morning to all my dear students. Welcome back to your science class. Today we are going to start a new chapter, that is chapter number 14, electric current and its effects. The topics which we are going to cover in this chapter are symbols of electric components, heating effect of electric current, electric fuse, magnetic effect of electric current, electromagnet, applications of electromagnet and electric bell. Today we'll study symbols of electric components, heating effect of electric current and electric fuse. We'll also study some basics relevant to the chapter. So let's start. Electricity is the most convenient source of energy. And we all know that it is very important because it is used to run many electrical appliances like electric bulb, television, stereo, refrigerator, washing machine, computers, laptops, etc., which we use in our day-to-day life. And we cannot think our life without making use of electricity. It is produced at power stations from where it is brought to our homes through the thin wire and electric pole networks, or even by underground cables or wires. Apart from the electricity generated from the power station, there is another source of electricity, that is electric cell or battery. In order to obtain electricity from a cell or battery, we have to connect it into a circuit. So for that, let's study the electric circuit. What is electric circuit? A continuous conducting path between the two terminals of a cell or battery along with an electric current flowing in is known as electric circuit. Here you can see an image. What is this? Usually we call it battery, but it's not a battery, it's a cell. A cell is a single unit device which converts chemical energy into electric energy, while a battery usually consists of group of cells, where the positive terminal of one cell is connected to the negative terminal of the next cell. The components of electric circuit are cell, bulb, switch, wire and battery. A cell or battery is a source of electric current. A cell have a positive terminal and a negative terminal. The positive terminal of the cell is connected to the one end of the switch with a piece of copper wire. The other end of the switch is connected to the one end of the bulb holder with another piece of copper wire. The negative terminal of the cell is connected directly to the other end of the bulb holder with a copper wire. If we open the switch so that it comes in the off position, then a gap is created between the two ends of the copper wire. Due to this, one terminal of the cell gets disconnected from the bulb and therefore the current stops flowing in the circuit. Therefore, when the switch is open, the circuit breaks and no current flows through the bulb. The bulb stops glowing. When the switch is in the circuit, which means when it is closed, then the switch is said to be in an on position. When the switch is in on position, the circuit gets complete and hence a current flows in this. This current makes the bulb light up. For example, when you want to light up the bulb, you go and switch it on. When you do so, you close the circuit. It means that the circuit is completed. And when we switch off the lights, the circuit is open. It means that no current is flowing through the bulb and therefore the bulb stops glowing. Sometimes the bulb does not light up even when the switch is in the on position. It means when the circuit is closed. This can happen only if the bulb gets fused. In an electric bulb, there is a thin wire called filament, which becomes white hot and glows when electric current passes through it. When the bulb gets fused, then this filament breaks. The filament of the bulb is a part of the electric circuit. So, when the filament of the bulb breaks, the electric circuit also breaks. Under these conditions, the bulb will not light up even if the switch is in the on position or closed. Then comes switch. A switch can be connected anywhere in a circuit. When we bring the switch of a circuit in the on position, then electric current will flow instantly through the whole circuit, due to which the bulb will light up. When the switch is in off position, then no current can flow in any part of the circuit and therefore the bulb will not light up or glow. Then comes the wire in which the electricity flows and therefore the circuit gets completed. And then there is battery, which we have already discussed that battery usually consists of group of cells. Battery normally consists of several cells, thus giving it a bigger size and makes it bulky as well. A battery is mostly used for heavy duty tasks. It is used in inverters, automobiles, etc. And they are even much more costlier as compared to cell. In battery, the positive terminal of one cell is connected to the negative terminal of the next cell. To represent the electric circuits in easy way, we use symbols. The symbol of cell consists of two parallel lines, one thin and long and the other one thick and short. The long and thin line represents the positive terminal of the cell, whereas the short and thick line represents the negative terminal of the cell. Since we know that battery is group of cell, therefore symbol of battery consists of two cells joined together. In the symbol for a battery, the positive terminal of one cell is joined to the negative terminal of the other cell. Thus, the symbol for representing a battery for three cells will have three pairs of long and short parallel lines connected to one another. The symbol of electric bulb consists of a circle having a semicircle with a small loop inside it. The semicircle with a loop represents the filament of the bulb. The switch is a device which is used to make or break an electric circuit. The symbol for open switch and closed switch are as follows. A switch is also sometimes called as a key. The connecting wires are represented just by drawing a straight line. These straight lines can be horizontal as well as vertical. It is very convenient to represent various electrical components such as cell, battery, bulb, etc. by symbols. By using these symbols, electric circuits can be represented conveniently by drawing their circuit diagrams. What is circuit diagram? It is a diagram which tells us how the various components in a circuit have been connected by using the electrical symbols of the components, which is called as circuit diagram. We usually represent an electric circuit by its circuit diagram. Here you can see the image of a closed circuit and an open circuit. Heating effect of electric current. The production of heat in an electric device due to the flow of electric current is called the heating effect of electric current. You must have seen an electric heater used for cooking or an electric bulb or room heater. When these appliances are switched on after connecting to the electric supply, then their elements become red, hot and release the heat. This happens due to the heating effect of electric current. The degree to which a material opposes the passage of current through itself is known as its resistance. Actually, when an electric current passes through a high resistance wire, electric energy gets converted into heat energy, and this heat energy heats up the wire. Element. All electrical heating devices consist of a coil of wire called an element. When these appliances are switched on, then their elements become red hot and release heat. There are some electric appliances such as immersion heaters, hot plates, iron, geyser, electric kettles, hair dryers, etc., which have these elements inside them. So that's it for today. In our today's class, we have completed the basic introductory part. Then we completed the electrical components and their symbols. After that, we completed electrical circuits. Then we completed the heating effect of electric currents. In our next class, we'll move ahead with the rest of the topics. Till then, take care, study well, and see you in our next class.